Bueno, hola, pues bienvenido a otra charla de nuestro ciclo de charlas científicas del Centro Oceanográfico de Málaga. Hoy tenemos la suerte de contar con Mohamed Reda, del Instituto Nacional de Investigaciones Pesqueras de Marruecos y de la Universidad Hassan II de Casablanca. Y hoy precisamente lo que nos va a presentar es pues, su tesis que ha defendido hace muy poquito, según me acaba de contar Lidia, el mismo sábado. O sea que está muy reciente. Está aquí a través del programa de cooperación internacional de AICI, de la Agencia Española de Colaboración Internacional, bajo la tutoría, ¿no?, de Lidia. Y nada, como siempre, mi presentación es breve y os dejo con Mohamed.
Gracias. Hello everyone. Before starting my presentation, I would like to express my deep gratitude to the EU Center of Malaga for welcoming me to my training here, and also my honest thanks to Dr. Lydia, my supervisor during my training here, as well as the whole Plankton Lab team for their support and assistance. Finally, big thanks to all of you for coming today to attend my presentation. It's an honor. So in this talk, I will present the main finding of my research conducted during my thesis in Morocco, which I defended just 2 days ago. While the topic of my thesis is about ecology and structure of zooplancton community in the southern western Mediterranean Sea of Morocco, which has been carried out in collaboration between my university Ain Choc of Casablanca in Morocco and the National Institute of Halieutic Research. This presentation is structured into 6 chapters. First part is a literature review describing the general characteristic of Mediterranean Sea, highlighting the uniqueness of its ecosystem, and providing an overview of zooplankton and its ecological role in marine system. Secondly, data about methodological adopted during my thesis, including sampling and processing technique, as well as analytic tools used. Then I will represent the results that are divided into 3 sections. First, describing the hydrological characteristic of the over material during the study period, and after that, examine the qualitative and quantitative composition of zooplankton and analyze the spatio-temporal variation in community structure. Finally, I will conclude with a summary of all of this. So, as you know, the Mediterranean Sea is a semi-enclosed basin connected 3 continents. It is one of the planet's 10 biodiversity hotspots, home to approximately 10% of the world's marine species, despite covering only about 1% of the global ocean surface. It hosts over 17,000 species across a range of unique habitat, but faces increasing threat from pollution, overfishing, and mass tourism. While this exceptional biodiversity is particularly evident in the Moroccan Mediterranean, a strategic area influenced by both Atlantic and Mediterranean forces, as illustrated in this map, the Alboran Sea, located at the Atlantic-Mediterranean interface, is oceanographically complex and biologically productive. Circulation here and water exchange here create favorable conditions for high biological activity. The dynamic system is influenced by the eastern and western Alboran Sea and the central circulation Sea, active only in summer, which affect water mass transport and distribution. The Atlantic jet, a surface current entering from the Atlantic through the Gibraltar, bring nutrient-rich water into the Mediterranean, and is composed by a deeper counterflow. And thermal and hauling front create retention zones that further enhance nutrient accumulation. This hydrodynamic condition results in some of the highest productivity level observed in the Moroccan Mediterranean relative to other parts of the basin. At the heart of this productivity lies the Mediterranean food web, which functioning as an energy transfer network where plankton plays a pivotal role, linking primary production to the predator. So the zooplankton in particular occupy a central place in pelagic trophic network. They regulate phytoplankton production and help counter eutrophication, as well as serving as a key food for fish. This group includes a fascinating diversity of organisms classified by size, lifestyle, and ecologic functioning. My research focused on mesozooplankton, a major component of pelagic ecosystem. So studies of mesozooplankton in the southwestern Mediterranean Sea, and especially along the Moroccan coast, remains scarce as so in this histogram, where all the previous studies confirm that copepod dominates some seasonal abundance trend. There is still limited understanding of how environmental variability influences the spatio-temporal structure of this community. And to address this gap, we formulate two key questions. What is the composition and abundance of zooplankton in the Moroccan Mediterranean? And what is the relationship between community structure and environmental parameter? So the main objective of this thesis is describe the spatio-temporal variability of mesozooplankton in the Moroccan Mediterranean and its relation with environmental factors to better understand the structure and functioning of pelagic ecosystem. This is achieved by first characterizing hydrological property and their spatio-temporal variability, then determining mesozooplankton taxonomy, composition, and abundance, and finally establishing a link between mesozooplankton community, structure, and environmental variability. And the methodology for achieving this objective is a combination of the following. First step is sampling and in situ measurement. So the study was conducted along the Moroccan Mediterranean coast for Madiaq to Saidia across 3 oceanographic surveys, one in each season, summer, spring, and autumn. All sampling was carried on board an oceanographic vessel, El Amir Moulay Abdullah, covering coastal zone up to 500-meter depth. So at each station, physical and chemical parameters were recorded using a CTD, temperature, salinity, and oxygen, and water samples were collected using for nutriment and chlorophyll I for analysis. And the zooplankton was collected with oblique tools, with using a bongo with the mesh size of 150 micrometer. And one fraction was preserved in formalin for taxonomy, and the other for using it's used for biomass estimation. And in the laboratory, nutriment concentration were measured using standard calorimetric method with an auto-analyzer, and chlorophyll I and indicator of phytoplankton biomass was analyzed by flowmeter after acetone extraction. While zooplankton sample fixed in formor are used in identification under a stereo microscope, focusing on zooplankton and cladorchaire species, though other groups were also included. Organism counts were performed using a subsampling method to estimate density. And concerning the frozen zooplankton sample, they are used to measure the wet biomass. And to characterize zooplankton structure, we calculate several indices: the density, the relative abundance, the frequency of occurrence, the species research, the Shano and Pielo index. And 2 many metrics were used for statistical analysis. A PCA explored the relation among hydrological parameters, Bray-Curtis based on cluster, grouped station based on faunal similarity, and NMDS to visualize station relation by species component. And simple analyzed to identify species contribute the most to intergroup dissimilarity. Finally, this LM model and DBRDA plot were used to relate zooplankton abundance to environmental variables. So the first section of results obtained in the hydrological parameter of my study area, where the spatio-temporal analysis of physical and biological parameters over the 3 seasons revealed that the temperature ranged from 16.3 in spring to 23.3 in autumn, with a clear west and east gradient in summer and autumn. And salinity showed the seasonal variation average 36.4. Here we can observe that offshore station showed stronger vertical salinity variation, mainly in the offshore station compared to the coastal. And for oxygen, it was relatively stable with a decreasing trend through the eastern part of the study area. And the chlorophyll I concentration reflected the phytoplankton bloom, peaked in spring following nutrient trend. And nutrient concentration, nitrate, phosphate, and silicate were low to moderate, typical of Mediterranean oligotrophic water. And it was highest in spring, April, and lowest in autumn, indicate that the vertical mixing was incomplete. And for PCA profile, it revealed too many groups of stations per season. During the fall season, the east is warmer and more saline, while the west is colder, better oxygen, and richer in chlorophyll. During the spring, nutrient-rich coastal season contrast with offshore season, which are salter and poorest in nutriment. While no gradient was observed in autumn. And based of all these results, we were able to characterize our region from hydrological part of view, highlighted complex seasonal and spatial dynamic. Our results showed a meridional gradient in the spatial variability of the water physicochemical parameter during the 3 seasons studied. The western region has lower temperature and salinity value than the eastern region. The lower value of these 2 parameters in the western zone were explained by the influence of the Atlantic water from the Strait of Gibraltar. In terms of temporal variability, the seasonal variation were observed for temperature, while salinity remained relatively stable. These nutrient salts have a direct influence on phytoplankton production, given that the Mediterranean is an oligotrophic basin. Chlorophyll I concentration is dominated by winter-spring bloom and controlled by vertical mixing. And the results of our study highlighted maximum concentration, particularly in spring, and the same was observed for chlorophyll I. Let us now move to the result of our analysis of mesozooplankton sample, where the zooplankton biomass and density showed a seasonal variation, with which the biomass was highest in spring, particularly in the east, and the density were highest in autumn, with the general cost to offshore decrease gradient. And for the season, copepod is the dominated group, followed by gradocer, whose presence peakly in summer and declining in spring. This component remains relatively stable despite seasonal variation, and we find like 50 groups. The distribution of copepod reflects that of total zooplankton. A decrease in coastal offshore gradient is observed with area of high density varying according to the season. 3 species dominate gradocer. They are very abundant in summer, especially in the west, but virtually absent in spring. and autumn marks their return, once again confirming a clear seasonal patterns. Appendicular are present throughout the year, but in low density in spring. The peak is observed in autumn with a high concentration in Al Husayma Bay, further highlight the importance of this area. Ketognath is a predator of zooplankton, are well represented in summer, mainly in the west. Their presence in autumn is more moderate, but remains significant. This may reflect active trophic dynamics. Siphonophore and salp, the gelatinous groups, remain a minority over. Siphonophore are more common in summer and spring, with a west-east trend in autumn, and salps follow a similar patterns, with a sharp decline in their presence in autumn. Taking the dominant group, the copepod, we have identified 35 species with more or less significant variation in the number observed between seasons, and the highest number recorded during the autumn. While diversity in the Andes, such as Sano and Pielo ictability, showed that only in summer was the copepod community more structured in the west than in the center or east, and for the other season there was not visible a gradient. Still focusing on zooplankton in copepod species, Acacia closi saw a clear seasonality expansion peaked in density in the fall, indicated adoption to cooler and more productive conditions. And for Onkea venusa, a cyclopoid species becomes particularly abundant in the fall, with density increasing, probably reflecting an increase in coastal productivity. Temora stylifera, a key copepod species, saw a marked presence in almost all stations, but with strong seasonal variability. It's most abundant in autumn, particularly in Al Husayma Bay, where it reaches a remarkable peak here. And for Paracalanius parvus remains the dominant species with 100% of occurrence. This species richness is highest in autumn, showing an increased diversity during this period. So a multivariant approach was used to analyze the spatial variability of this community, highest the spatial heterogeneity of their structure, and identified the main spatial discontinuity and deleted the different zone of Moroccan Mediterranean. So in summer 2017, NMDS analysis clearly distinguishes three zones. The western zone is homogeneous, while the eastern zone is higher dispersed, reflecting marked heterogeneity. And the cluster confirmed the uniqueness of these three identified zones, while the sample analysis confirmed that the eastern zone is the most heterogeneous. It differed greatly from the western zone. And species such as Pennilia avistros, it's a cladocer species, and Temora stylifera highlights the difference between this zone. And the DBRDA redundancy analysis demonstrates a significant correlation between environmental parameter and zooplankton community composition. The relay test confirmed this relationship with high significative. And the analysis revealed that salinity is the most decisive variable, followed by longitude and depth. With these two principal axes explain more than 93% of the model variability. And the first axis clearly different between western and eastern stations based on salinity and geographic position, while the second axis contrasts coastal and offshore stations based on depth. And in spring, NMDS results demonstrate that the zones are less contrasting than the previous summer. The eastern zone remains well defined by the station in the center and divided between east and west. And for simple analysis in this season show greater homogeneity in this community. The dominant species are broadly the same, but with variation in their contribution depending on the zone. While environmental factors have less influence than in summer, geographic location remains important, as do temperature and salinity. And the related similarity matrix test give a correlation level of 1.4%. And the DBRDA revealed that the first two axes explain 91.44% of the variability. In autumn, the community structure becomes even more uniform. No clear spatial trends are detected. This could be related to a period of ecological transition. And the simple result reveals greater heterogeneity in the zooplankton community in its zone compared to spring. And the relate method did not show any significant correlation between the dissimilarity matrix calculated from this environmental parameter and the dissimilarity matrix calculated from zooplankton abundance. The significative level is higher, 25%. So, as a summary of this section, the analysis of the spatial structure of this group revealed significant heterogeneity, particularly in east of Cap Three Forks, here, which stand out as an ecological unique area during the three-season analysis. Three major areas were delimited: the western area, the central, and the eastern area. The study reveals a contrast between the western, which is vast but homogeneous in terms of zooplankton, with low salinity and temperature, and the eastern zone, which is smaller but heterogeneous, with highest temperature and salinity. Environmental factors such as temperature, salinity, and depth significantly influence the community in the summer of 2017 and spring. And the Alboran here, the central and the west and east structure the ecosystem by modeling physical-chemical conditions and phytoplankton production, a key factor weakly correlated directly with zooplankton in this study. To conclude, this work was enable us to characterize the spatial distribution of environmental parameters and mesozooplankton community across three seasons. It has also enabled us to establish a spatial temporal analysis of zooplankton community in relation to local hydrological conditions. Spatial and seasonal analysis of environmental parameters revealed a double environmental gradient, the coast offshore and west-east. There was strong seasonal variability and maximum nutrient concentration, mainly in spring. And the influence of the Gir and Atlantic input via Gibraltar was also observed. And in this hydrological system, west-east and the gradient, and also the seasonal stratification, zooplankton responds to environmental variation by changes the biomass, the diversity, including copepod, which largely dominate the mesozooplankton assemblage throughout the year. And a peak in biomass was observed in spring. And the analysis of the structure of zooplankton community and their interaction with environmental factors is an essential part of this study. The results showed that environmental factors significantly the influence of organisms of zooplankton community, but in different ways depending on the season. With strong link being demonstrated for summer and spring, particularly for temperature, salinity, and longitude. This reflects the key role of the hydrodynamic Gir in the distribution of community via physico-chemical condition. And ultimately, this result confirmed that three major zones have thus been delimited in the Moroccan Mediterranean coast. Oh, gracias.
siempre, hay un turno de preguntas. ¿Se anima?
Yeah.
Thank you, Mohamed. Congrats for your work.
Thank you so much. Yeah.
Will you have access to phytoplankton community structure in your data set, or would you be interested in checking?
Yeah, there is another colleague working in us. They do the thesis. She do thesis about phytoplankton, but we have only 2 seasons common. We don't have the July season. For me, I work on zooplankton on July, but for her, she didn't do. So we managed to do an article in common between phytoplankton and zooplankton. She do the same thing for species and all phytoplankton species.
And what would you like to do next?
Yeah.
What would you like to do next?
Next.
What do you want to do now that you are finishing your...
Meta coding and also modelization. I start with modelization. I do like internship, but I will continue with this.
Okay.
And genetic. Thank you.
I have one question.
Yeah.
You have already published all these results, or
Yeah.
Okay, this is based on
Article.
papers.
Yeah. Yeah.
Congratulations.
Thank you so much.
I have a question about the transaction, first with copepods and after that with cladophores.
All right.
This is very common in zooplankton, this transaction along the year.
These two groups, yeah, it's the dominate all zooplankton in Mediterranean. But I find that cladophore in one season become more than copepod. It's a new things. Yeah, we see it.
And
So
this is of the reason that happened that. Have you something
to explain why, not yet. Yeah, maybe of the condition or yeah.
Cladoceras have a huge footprint. Cladoceras have a peak in the Mediterranean in summer, maybe in August, due to the high temperature. They are able to reproduce very fast, and some of them are parthenogenetic. And then they take advantage of the food, and they are able to reproduce faster than copepods. So usually the peak is in August, but in later years, the last decade, they are expanding their distribution. Their abundance peak is expanding towards the autumn because of the increase of the water temperature.
but the biomass is higher on copepods, right?
Yeah.
Yes, it's just the plants. So in the past was a short peak, like August, and then they disappear. Now to be August, September, October, due to climate, to the water warming.
So the temperature is a key factor.
Yeah.
Thank you.
Welcome.
¿Alguna preguntilla más? Está todo muy clarito, muy clarito. Bueno, entonces nada. Acordaros que el jueves tenemos otro.
No voy. Perdón. Ya estoy tomando así con todo el mundo para la semana.